Inside the immense territory of the universe, humanity has started to examine, in spite of our endless interest. We have frequently considered the presence of life beyond Earth, contemplating whether we are extraordinary in the universe. Anyway, a pivotal situation unfolded with the appearance of our first interstellar guest, Oumuamua, a component dissimilar to any we have encountered before. This ignited interest in the dark domains beyond our planet. Outstandingly, the regarded astrophysicist Neil deGrasse Tyson recently revealed previously unheard-of declassified pictures of Oumuamua, stirring interest in who could have sent this extraterrestrial messenger. The meaning of Earth's experience with Oumuamua and its implications are explored under the guidance of astrophysicist Neil deGrasse Tyson as we dig into the secrets surrounding this extraordinary interstellar explorer. In 2017, an unusual find using the Pan-STARRS 1 telescope by Robert W. introduced us to an object tearing towards Earth. The presence of Oumuamua lighted an intense change in our understanding of space and its unending potential outcomes. Regardless of its reputation, our information on Oumuamua has remained inadequate. Considering open interest, Neil deGrasse Tyson unveiled already prepared pictures of Oumuamua, sharing insights into its significant effect on our local planetary community. Prior to diving into the mysteries hidden in these long-fixed photographs, it is important to appreciate the charming essence of Oumuamua. On October 19, 2017, the Hawaii-based Haleakala Observatory mentioned a crucial observation of what appeared to be a comet or space rock, later identified as the first interstellar object recognized within our planetary system. Its unpredictable orbit and rapid speed suggested an extraterrestrial origin, earning it the name Oumuamua. To better understand its structure, astronomers compared it to similar planetary objects, like the asteroid 25143 Itokawa, which the Hayabusa mission visited in 2005. While Itokawa shared some features with Oumuamua, the interstellar visitor's elongated shape and lack of a tail set it apart. Adding to the mystery is Oumuamua's remarkable acceleration, akin to a bicycle suddenly speeding up without pedaling. Entering our planetary system from above, it came astoundingly close to the Sun before passing beneath the planetary plane, maintaining an extraordinary speed of around 196,000 miles per hour, indicative of tremendous dynamic energy. This speed is unparalleled by any human-made object, highlighting Oumuamua's unprecedented journey through our solar system. The high velocity of Oumuamua has prompted speculation that it could have originated from a binary star system. This hypothesis suggests that gravitational interactions within such systems could propel objects to high speeds. If Oumuamua did indeed come from a binary system, the gravitational forces from the stars could have sent it on its interstellar journey, explaining its extraordinary speed. Beyond its speed, studies have revealed fascinating details about Oumuamua's composition. It features a dense outer layer, likened to a carbon-rich crust, solidified by extensive radiation during its long journey through interstellar space. Beneath this protective exterior, Oumuamua shows an exceptionally dense interior, primarily composed of rock and potentially metallic elements. What distinguishes it is the absence of water or ice, setting it apart from typical comets or icy bodies. Furthermore, Oumuamua's surface has a reddish hue, a result of prolonged exposure to cosmic rays over millions of years. Many have sought insights from prominent experts like Neil deGrasse Tyson and Michio Kaku regarding Oumuamua. Strangely, Neil deGrasse Tyson refrained from commenting on the matter until significant evidence, including the newly declassified images, became available, leaving everyone eagerly awaiting his perspective. Some experts suggest that Oumuamua's elongated shape and light-bending qualities indicate it might be part of a larger structure. If Oumuamua broke off from a larger object due to an impact or other catastrophic event, it might have gained significant speed during the separation process. This suggests that Oumuamua's speed isn't inherent to its nature but could result from previous events. Comparisons can be drawn with comets and asteroids in our solar system, which travel at different speeds. While some comets can achieve speeds similar to Oumuamua, they often exhibit residual gas and dust due to their volatile composition. In contrast, Oumuamua showed no such characteristics, distinguishing it from known cometary objects. Similarly, most asteroids in our solar system move at much slower speeds than Oumuamua. For example, the typical orbital speed of the main asteroid belt is about 17,800 miles per hour, less than a fifth of Oumuamua's estimated speed. This discrepancy highlights the extraordinary nature of Oumuamua's speed and its separation from regular solar system objects. Some scientists speculate that Oumuamua may be more than a naturally occurring object. They propose that it could be an artificially created structure, carefully crafted by a high-level extraterrestrial civilization. According to this theory, Oumuamua's unique features might serve various functions. Its elongated shape could enhance its durability during interstellar travel, while its propulsion system might allow for precise navigation through the universe. Figures like Avi Loeb, an Israeli-American theoretical physicist and cosmologist, strongly support this hypothesis. Loeb even proposed a controversial theory that Oumuamua might be of extraterrestrial origin, suggesting it could be an artificial object or even a piece of alien technology. He argued that its peculiar properties, such as its elongated shape and unusual acceleration, could point to an artificial origin. This idea sparked significant discussion and debate within mainstream science, with many prominent scientists and astronomers expressing skepticism about these claims. The prevailing view among most researchers is that Oumuamua is naturally a comet or asteroid, with its strange properties resulting from natural processes. Wesley C. Fraser and other researchers used combined brightness measurements from various telescopes to study its rotational period. They concluded that no twisting could account for the observed brightness variations. Instead, the object seems to be tumbling in an excited rotational state, a movement unlike any seen before. This erratic rotation has puzzled scientists and led to several intriguing hypotheses. One theory, known as the spin-induced outgassing hypothesis, suggests that volatile materials beneath its surface are exposed to solar radiation as the object tumbles through space, causing it to degrade and produce small gas jets. These jets act as thrusters, applying force on Oumuamua and causing it to rotate unpredictably. Another hypothesis proposes that Oumuamua's tumbling motion could result from a prior collision with another object. It's possible that a rapid impact deformed its shape and set it into an irregular spin. However, the exact nature of such an impact and the involved object remain speculative due to limited observational data. Detailed examination of Oumuamua's shape, structure, and surface features could provide clues supporting these theories. To better understand Oumuamua's unusual motion, let's consider other celestial objects with similar behaviors. One such object is the asteroid 4179 Totatus, discovered in 1989, which exhibits a tumbling motion like Oumuamua. Researchers have proposed several theories to explain this phenomenon. TAT's capricious twist, including the Yurovsky FRV enclosure YP impact, concurs with this impact. Daylight applies a power on the object because of lopsided thermal radiation, step by step modifying its turn and prompting its unpredictable tumbling movement. Another model is Comet 67P/Churyumov-Gerasimenko, normally known as 67P, which also shows sporadic rotation. Researchers found 67P on September 11, 1969. This comet orbits the Sun and features a striking shape and surprising development, with two distinct lobes connected by a narrow neck. It belongs to the Jupiter family of comets, indicating that its origin might be traced back to the Kuiper Belt, a region beyond Neptune populated by icy bodies. However, scientists believe that gravitational disturbances caused by Jupiter's massive gravity pulled 67P into its current orbit. Regarding Oumuamua, researchers trust that outgassing and interactions with sunlight could have caused the unconventional acceleration and tumbling movement observed. Continued study and observation of Oumuamua and similar celestial objects will likely provide further insights into their nature and behavior, revealing clues about the mysteries of the universe. The release of volatile substances from its surface plays a significant role in its tumbling motion. As the ice on the comet's surface deteriorates due to solar radiation, it creates limited streams that act like engines, altering the comet's spin. The similarities between Oumuamua and these objects suggest potential common factors responsible for their surprising twists. Further examination and detailed analysis of these objects can provide valuable insights into the nature of Oumuamua. The origin of Oumuamua has also been a subject of much speculation. Some scientists have proposed that it may be a fragment of a larger body ejected from its home star system due to gravitational interactions or a catastrophic event. This release may have imparted an initial spin to Oumuamua, which has persisted throughout its interstellar journey. The exact process by which Oumuamua was launched and its subsequent trajectory remains uncertain, highlighting the need for further data and investigation. However, there is a possibility that Oumuamua is the result of an impact between two objects in a distant star system. The subsequent debris could have been ejected into interstellar space, with Oumuamua being one of the fragments captured by our local planetary system's gravitational pull. Without further evidence, these theories remain speculative. Detailed assessment of Oumuamua's composition, isotopic ratios, and surface features could provide clues about its origin and shed light on the processes involved in its unusual spin and movement, as described in these pictures. The absence of visible emissions has perplexed scientists significantly. This lack of visible emissions precluded the possibility of Oumuamua being a typical comet or asteroid, presenting an intriguing mystery that required further investigation. There is a possibility that Oumuamua's lack of outgassing can be explained by it being a dormant comet. In typical comets, the icy composition breaks down as they approach the Sun, resulting in an emission trail. However, if Oumuamua had lost most of its volatile materials due to repeated close encounters with stars during its long interstellar journey, the lack of visible radiation could be explained. High radiation from these encounters might have stripped away Oumuamua's volatile components, leaving behind a rocky or metallic body without the usual coma. This opens the possibility that Oumuamua could be an interstellar asteroid. If Oumuamua were an asteroid, the absence of a coma could be explained, as asteroids generally don't show the same outgassing behavior as comets. However, Oumuamua's elongated shape remains a mystery. Asteroids in our solar system typically have more irregular shapes. Some researchers suggest that its elongated shape could result from gravitational forces experienced during close encounters with a star or planet in its parent star system. Also, the asteroid Bennu, the target of NASA's OSIRIS-RX mission, offers an interesting comparison. Bennu, classified as a primitive carbonaceous asteroid, did not display any visible outgassing during its close encounters with Earth. However, this lack of visible emission was expected, as Bennu's surface was predominantly rough, with minimal volatile content. This illustrates that asteroids, unlike comets, generally do not show visible emissions, aligning with the idea that Oumuamua could be an interstellar asteroid. What were Neil deGrasse Tyson's views on the declassified pictures? After the release of the declassified pictures, Neil deGrasse Tyson took on the responsibility of carefully analyzing and interpreting the details and potential implications of Oumuamua. Tyson generally emphasizes evidence-based inquiry in his discussions on Oumuamua, stressing the importance of approaching the subject with skepticism while exploring the fascinating nature of Oumuamua as a messenger. This approach mirrors the essence of scientific inquiry, where different hypotheses are proposed, tested, and either confirmed or rejected. Tyson suggests that the universe might be far more mysterious and complex than our current understanding. He also views Oumuamua as a test that challenges our technological and scientific abilities. How we observe, track, and study it demonstrates our evolving capabilities in space observation and exploration. Furthermore, Oumuamua challenges our scientific models with its surprising acceleration, unique shape, and trajectory, which defy conventional explanation. Tyson considers this to be a test of our scientific flexibility. Can we adapt our hypotheses and models to accommodate this new information, or will we try to fit it into existing frameworks? Oumuamua's rapid entry through our planetary system required swift, coordinated efforts from the global academic community. Tyson sees this as a test of our ability to collaborate, share information, and pool resources in the face of an unexpected cosmic event. It raises questions about how we responded to this challenge and what lessons we have learned to prepare for future celestial visitors. Tyson also explores the possibility that Oumuamua could be an interstellar messenger sent our way, presenting not just a challenge of detection but also of interpretation. Could we ever decode a message or signal embedded in its shape or behavior, and if so, how would we respond? These questions remain unanswered, and the search for answers continues.